Thanks everyone for coming. Today I will present SoarChain to you, the decentralized connectivity and data infrastructure for vehicles, and how we're innovating mobility with the Interchain stack. The overview is basically, I'll just talk about me a bit and then introduce SoarChain, its purpose, why we use it for a decentralized data and connectivity ecosystem and an infrastructure, and then how blockchain plays a critical role in this for enabling the secure and efficient communications between vehicles, cloud, and other nodes. And then I will go through the SoarChain and the Interchain stack, what we're using, how we're using, and the benefits of using the Interchain stack, which is like which had been a long journey for us. And then I'll touch up on some real-world use cases of SoarChain with the application ecosystem, and finally I'll go over some future directions. Who am I? I'm originally from an electrical and electronics background. I'm co-founder and CTO of SoarChain. I've been in automotive since 2012, and I got into the crypto space in 2014. I was just trading back then. My journey with autonomous systems actually started in 2016. I have been developing autonomous vehicle hardware and software since then. My interest in the blockchain development actually started in 2017. I've been experimenting with different protocols, like especially Byzantine fault-tolerant consensus, proof-of-stake systems, things like PBFT, Honey Badger BFT, and Tendermint since 2020. I was introduced to the Cosmos ecosystem in 2021, which was a game changer for me, to be honest. And since last year, I've been leading the development efforts of SoarChain. And outside of work, I love cats, botany, and outdoors, and I also love producing music. So the general introduction will be that I'll go over each and every topic here. To introduce SoarChain, it is a decentralized mobility network to enable a data and connectivity infrastructure for mobility. It is specifically designed for mobility, the extreme amounts of data and the high mobility nodes. So our goal is to basically transform how vehicles collect, process, and utilize data, connectivity, and computational resources. When you look at an average modern vehicle, it can generate up to 2 terabytes of data per day, and this will only go up as the autonomy levels will increase. And this data is extremely valuable to countless parties. It can be the nearby vehicles, it can be the car manufacturers, the tier 1 suppliers of these car manufacturers, service providers that are in mobility, and basically anyone who's got something to do with this data and the resources that the cars can provide. But right now, when you look at it, there is no incentive structure in mobility to incentivize people so that they can deploy this technology and continue to support it. We have been approaching this from multiple angles. We have been working with car OEMs, car manufacturers. We have been working with the retail, and the issue about the automotive industry is it moves very slowly. So although these big companies, they want to use this technology and they want to implement it in their cars, they just can't because it's really slow moving. They have very long innovation cycles. So that's why we opt in to provide this technology to the end user as well, where we can actually grow the network much faster and give the control of their data that they have been generating to the end user. And most importantly, by doing so, we're enabling an open innovation ecosystem in mobility, which is lacking right now because it is very closed. It's not something like developing an application for your phone. It's not open, but it's got a lot of potential. It's a $400 billion, $500 billion industry, and it's very closed. The other aspects are the Motus is the secure hardware which we are providing. It's an open source hardware. It helps secure the network, the data, and verify its integrity, plausibility, and authenticity. We're using two very important connectivity paradigms called vehicle-to-vehicle and vehicle-to-network connectivity. We have implemented something called proof of availability, which enables the vehicles to communicate with each other and verify each other's data, so that at the end, this verification would become a proof, and only that proof would be verified by the main L1, so it can be thought of as an L2 solution that's running on the device that's on the cars. And when we look at the SoarChain ecosystem, it's built up from multiple participants. There are the road users, obviously. These are the drivers, vulnerable road users. This can be anyone who's not a car that's using the road. We have the runners, which are the generic compute nodes, which is very important to our purpose because it actually receives these extreme amounts of data and processes it in a way that it can become usable for the data consumers. And the token economy model, we have been actually working on this a lot. We're actually also part of the Interchain Builders program, and we have been working on this for a lot of time. We have been examining many of the aspects, the shortcomings of the current proof of stake chains token economy. So we've designed it in a way so that it actually depends on the usage of the network, and rather than just like a constantly increasing or decreasing number. And when we look at the real world use cases, I think this part is the most important part, because as an L1 network, we need to enable new applications, real world use cases, which are actually solving the problems of mobility as we currently have. So it can be anything from connectivity performance to predictive maintenance, insurance applications, road conditions, device management, things like EV charging, teleoperation, leasing, loans, anything that you are currently using and that has some shortcomings in the mobility sector. This is the Motus device. So this can be thought of as a hardware wallet which you plug into your vehicle, and it verifies your data that's coming from the vehicle, and it does some plausibility checks, and it also has a hardware chipset component which actually is very similar to what Ledger or other hardware wallets use. And also each hardware added to the network strengthens the network further because as I mentioned, the devices themselves are verifying each other before sending out the whole data to the chain, and it creates this intermediary scaling layer.
Where in the car is it plugged in?
In the car, it's actually plugged into the OBD2 port, which is the onboard diagnostics port, which is pretty common in all the vehicles manufactured after 2008. And even in the US, many of the cars manufactured after 1996.
Is it low frequency? What is it, 900 megahertz?
So there are two different models. The one you see on the left is like the Pro version, which is more designed towards developers and power users. It has this V2V, vehicle-to-vehicle aspect. It uses 5.9 gigahertz. It's a reserved but unregulated band that's specifically reserved for vehicle-to-vehicle communications. So that's actually how we're bypassing an intermediate layer such as a cellular network, and vehicles directly communicate with each other, and they only backhaul to some like internet or some backhaul network only for sending the proofs to the validator network.
So unlike helium, you don't need line of sight, right?
Actually, this does need, I wouldn't call it line of sight, but this does need line of sight, and it has even less range than the helium's LoRa, but in exchange for higher throughput and higher reliability, it's actually a version of cellular physical layer designed specifically for vehicle-to-vehicle communication. And it has a range of 1 to 1.5 kilometers, or like 1 mile. But that's the only range that your the cars are relevant to you, because if you have other cars further than that, it's just not relevant to you. So this physical constraint fits perfectly with the purpose of the network. The one you see on the right is only working in the vehicle-to-network configuration, and it's like a way for us to get like entry-level users to the network as well.
And it works with proof of coverage. For example, you get tokens, or it's like an economy.
Yeah, it's something similar to the proof of coverage, which actually I will come into in the other slides. It's actually the proof of availability. So yeah, and this is the whole domain. We have the vehicle-to-vehicle, vehicle-to-network, vehicle-to-infrastructure, and vehicle-to-pedestrian, all enabled through this protocol. And SoarChain actually, on the protocol level, it incentivizes people to deploy this technology to their cars and join the proof of availability, where each vehicle, they exchange messages, and these messages gets verified, a proof is created, and then that's verified by the network itself. So this is the whole ecosystem, and when I come to the SoarChain and the Interchain stack parts, as you know, I really want to tell this story. So initially, when we started developing SoarChain, we started everything from scratch. And as you said, Helium, we were like very early adopters of the Helium as users, as power users, and we knew everything about their proof of coverage, the consensus mechanism that lied under it, and we basically started developing on their consensus mechanism, which is called the Honey Badger BFT. And then the reason for that was basically to have a fully asynchronous consensus mechanism, which is needed especially for a high mobility and a wireless ecosystem. When you look at Helium, it's not high mobility, actually, it's stationary, and they even needed this asynchronous system. So we even needed like a better thing. We've experimented with the more advanced versions of Honey Badger BFT, which is called BEAT, B-E-A-T, and even some research grade versions of them. And we have managed to develop something that works solely on these devices, where they get into a consensus. They use some threshold public key encryption for exchanging keys, etc. Then all the development work just got out of hand really, really quickly. We needed to develop the networking layer. We needed to develop something that resembled ABCI, because we also wanted this to be a modular thing. We didn't want like a hard-coded single monolithic structure, because that's not the paradigm anymore, and it makes more sense. So while we were actually trying to develop something similar to ABCI, we actually started experimenting with the Tendermint core, and then what we have been able to achieve in 4 to 5 months, we were able to achieve in about a month with Tendermint core. And then we've discovered Cosmos SDK, which further decreased the cost of development in terms of time and resources to even maybe like 2 weeks or so. Of course, I'm mentioning the initial implementation. And as we move more and more into the Cosmos ecosystem, we also noticed that the VM is very flexible, and we're in fact able to develop these custom modules without actually dealing with the all lower level details. I just want to mention some of the custom modules, because these are also like critical to our use. We have implemented a DID module, decentralized identifiers. It's basically a way to assign unique identifiers to the entities in the network. It can be thought of as a similar like a registry for vehicles, for applications for the drivers, basically anything that needs to be kept within the blockchain. It's now kept through the DIDs, which are even interoperable and designed according to the W3C standards. We have the DPR. This is the data provision infrastructure. It is a way for the data consumers who are actually the dApp developers in this case, to request for data from the data generators, who are the drivers and the car owners in this case. And the car owners specifically and explicitly need to allow the usage of their vehicle data or some resource on their vehicles through this data provision infrastructure. Again, it is a custom module. We have implemented something similar to Osmosis's Epoch module. It's a bit simpler than that, but we needed this because the proof of availability actually depends on certain time intervals to be counted as blocks. The VC is actually the verifiable credentials. It's kind of very coupled with the DID module, and it can be thought of as a sub-module of the DID, where verifiable credentials can be assigned by some entities in the network who own some certificates, such as the car manufacturers or some department, etc. We're also working on something called the computational proofs. That's basically a way to prove that a computation has been in fact done by these devices or any type of node in the network. It's still a work in progress, but we aim to have some succinct proofs on the custom module VM level where any type of generic computation can be verified. The DPKI is the decentralized public key infrastructure. This is again coupled with the DID parts. This is a way for us to store the certificates, store the public keys, and provide them in a decentralized way. The POA is the proof of availability, and SoarMint is our custom minting module, which depends on certain usage parameters within the network, where it's a challenge-based system. So vehicles, these devices get challenged in periodic intervals, and according to the number of challenges, which reflects the usage of the network really, really well, the minting of the rewards are actually decided upon, and that really helps us control the inflation and also give a fair distribution of the tokens according to the usage, rather than just minting tokens blindly, which is also reflected in the staking rewards as well. So yeah, this part is basically the whole structure. Also, we're CosmWasm enabled, meaning that Rust smart contracts can be written. That's the whole idea. Basically, we have more and more dApp developers. Also, the WASM module is actually connected with many of our custom modules, so you can do cool things like querying car data or static data from within the WASM module itself. This is a bit of too detailed maybe, but the overall idea is that the Motus Mini is the device. It uses the mobile app to connect to the internet. The data is collected from the car, from any environment, and then it's timestamped and signed. It's signed by the secure element, and then through the mobile app, it's sent to the runner devices. As I said, runners are the generic compute modules, and then once the runner is ready for a challenge, it claims that it sends a claim to the challenger node. Challenger nodes are much fewer in terms of their numbers. If there's like 1,000 runners, there's a single challenger for 1,000 runners, and then challenger asks some random Merkle leaves from the runner, which was created from the initial messages received, and then the challenger creates a proof out of this. If the proof is correct, then it's sent to the SoarChain core. If there is malicious activity or the proof cannot pass due to some double spent kind of action or some incorrect signatures, and then it sends a punish TX, which actually reflects to the score of that specific device. When we come to the challenge-based tokenomic system, I've already mentioned it, but there are two aspects to it. First is the scores of the vehicle. As long as a vehicle is honest and connected to the network, their score keeps increasing. It starts at 50. It can be 100 at maximum, and unless they do something malicious, their score keeps increasing, but the rate of increase decreases as it increases. And then according to the number of challenges in the network, that many tokens are minted, but they're also compared with the previous day's challenges, and if there's an increase in the challenges, then the reward per challenge decreases a bit, but not that much, so to not make people stop the mining process. When we come to the benefits of using the Interchain stack in SoarChain, basically there are multiple aspects to it, but these are the main things that we have been actually benefiting a lot. So it's basically been instrumental in bootstrapping the SoarChain network. As I said, 6 months of work become like a week work. When you scale that, of course, like years of work, maybe in 6 months, 7 months, we can actually focus on the core business itself and reuse all the existing modules. And its modular architecture also made it easy to develop custom modules. Things like proof of availability or data provision requests, and also the adjustable cost of computation and very flexible gas architecture, gas calculations also helped us developing. Cosmosm, it's really, my personal opinion, I even like it better than Solidity contracts. It provides a flexible and upgradable smart contract platform, and we're able to also connect them to the custom module, which gives further flexibility to the whole architecture. And this was especially important for us because as a layer 1, our goal is to attract developers so that they can develop applications on top of SoarChain. So we needed to make sure that we had a platform that they can actually work on. The IBC part, this is something we're very excited about, interested about. Haven't been able to work on it a lot, but many of the Cosmos SDK and IBC-enabled chains will help our network to also scale. Things like Secret Network, things like Somalia Network. We have many different plans to utilize cross-chain asset transfer and the functionalities that they provide in our chain to further scale the network. And of course, the community, I cannot not mention it. Of course, the ethos of building and decentralization it aligns perfectly with our vision in SoarChain, and also the community's commitment to open source development, and again, the principles of decentralization. It ensures that our network remains open, transparent, and secure. This is like the ecosystem. I've already mentioned this one. We have the road users, challengers, runners, validators, developers, and the industry. And SoarChain, as SoarChain, we're trying to glue all this together in a single trustless network.
Question?
Yep.
I'm trying to understand what is this challenger? How it is connected with or not, with validate or not?
Challenger actually is sending challenges, random challenges to the runners to check whether they have been creating these messages in a correct way, in an integral way, in an authentic way, and only a subset of the messages that these runners have been fixing into a Merkle tree, only a subset of them is asked. So they need to be honest about the whole thing, because any kind of random leaf can be asked to the runners. And then once the challengers receive this data, they create a proof out of it. And from the validator's perspective or the network perspective, it's just another computation needs to be made, and it's almost agnostic. It's like just another transaction.
It's like an additional consensus.
Yes, but without the consensus, because it doesn't need the consensus. We initially designed it in a way that it would also have consensus, but then you'll have like layers and layers of consensus. It doesn't make sense.
It's sort of like a node.
Exactly, it's a node. The idea is that it will be running right now. They are all cloud nodes to ensure the testnet stability. But with the Pro device, Motus Pro device, it's a really computationally resourceful device. They will be able to run these runners, because these runners scale with the network, scale with the number of cars, and you constantly need to increase. It's not like a active set that stays maybe around 100 or 150. If we don't scale the number of runners, then the network will be burdened a lot.
Technical idea for scalability.
Yes, exactly. And since
Like an aggregator, right?
exactly, and you can choose to become a runner or not. It will be very user friendly in the future, and you will be able to actually become a runner with your car. This is especially important for the EV domain, because the EV vehicles are actually always on, and you can utilize the idle compute power, connectivity, and any resource of that EV, because it's actually sitting there and it's on. And we have been also working with some car manufacturers about some POCs on this as well. So that's also how we expect to scale. We're obviously depending on some EV adoption. This is just like the applications that could be possible, some subset of the applications. Some of these are already developed as POCs. Some of them are being worked on as we speak by some individual teams that will be developing on SoarChain. Things like ride sharing, road conditions monitoring, and the V2V aspect. When you go to the left, you see the V2V dApps. It depends more on the vehicle-to-vehicle communication and that direct communication, which needs low latency and high reliability, and that's how we're able to enable road safety and collective perception applications. As a future outlook, I mentioned interfacing with other IBC-enabled chains, so this is like a very exciting thing for us. The second part is also probably one of the main purposes, not purposes, but the goals that we want to achieve, to have car makers, tier ones, or companies or entities or communities large enough to have a stake in this ecosystem, and hopefully have a balanced stake, have each of them distributed evenly, so that they would also validate the system, because they're also very interested in this validation part. And what we envision in the future, a car manufacturer will also be a validator, because they will hold so much stake in this ecosystem. We will be diversifying the hardware types and manufacturers. We will be open sourcing the hardware with the mainnet, and including more and more manufacturers, because we're just a team. We're just a single manufacturer, let's say, and obviously we're not going to be imagining all the possible use cases and different applications that our hardware can unlock. Also, we're working on the edge AI running on cars. This is both for the infotainment system, for the user-facing systems, as well as some pre-processing steps for the collected data from the car. Again, hardware collateralized stablecoins, this is something we have been working on, and this will also be something very exciting for the whole ecosystem. The implementation of fully homomorphic encryption, this is also we've been working on the R&D level. This will basically enable the user or any data generator to completely use the system in a trustless way. It's not end-to-end encryption. It's not ZK proof, although it can be thought of as a ZK technology. It will make our users access an ultimate privacy. And also, this is probably like a bit of an overreach, maybe in 5 years, 10 years, ZK crypto accelerator ASICs to the higher end hardware will become a standardized thing as the prices go down, which will further decrease the prices of these hardware. And yeah, with this, it was the end of my presentation. And please add me on Telegram to chat about any of these topics. SoarChain.com is our website. Soar_chain is our Twitter account, and you can email me through my Soar Robotics email. Thank you. And actually, we did the QA, but please.
How hard is adoption, like to sell the device, and like it's super hard because Helium had this incentive. I actually got stuck with Helium because I bought 80
Yeah.
and I couldn't find the rooftops to install it.
Yeah, this is a bit, I think this is a bit easier because,
I bought them, I was going to buy them earlier and I didn't, and then I bought them late. They shipped, they took a long time to ship. When I got them, I thought it was going to be easy to find the rooftops. So hard.
yeah, that,
Yeah.
provided.
Yeah.
I mean, it's,
So I lost a lot of money.
when you think of it, you have like people, car is a bit more of an accessible thing, at least. It doesn't even have to be a car in the medium term. Right now, you need some kind of car that's manufactured after 2000s. And the adoption is actually pretty good because we're also rewarding, that's the incentivization part. You get rewarded by participating in the proof of availability concept, which you just directly participate by plugging this into your vehicle. And in terms of the cost, it's much more cost efficient than the Helium miners. I mean, back then it was like what, $400, $500 maybe. Now they don't even sell, but it's around like $60 or so. So the adoption is not really slow.
Maybe you can become like them, like a foundation, and let manufacturers.
Yeah, those are all actually in our roadmap. But yeah, thank you for the suggestion.